as power plants running on fossil fuels heat up the Earth.
The whole system is hanging by a thread.
Scientists race to find a better, greener way.
This is really exciting because it happens even faster than the first steps of photosynthesis.
The search is on for clean, renewable energy. How about harnessing the power of the Gulf Stream to make electricity?
We have an enormous resource just off of our coast here.
Tapping the immense heat at the Earth's core.
We have to go deep into the Earth.
The city that leads the world in green energy.
Here we try to produce as much energy as we consume.
Innovative ways to power our planet and forever change the way you live.
It's an untapped resource.
It's a green energy revolution.
The world is using a lot of energy right now. Most of it's coming from oil, gas, and coal.
Scientists say fossil fuels must be replaced by clean, renewable energy, or else
We will run into more problems of climate change, nuclear proliferation, and so on, and those could become very unmanageable and make the world a very unsafe and unpleasant place.
the biggest change will have to happen in the United States, which gobbles up a quarter of the world's energy and imports most of it.
We're so dependent on other nations, we really have no energy independence.
And Florida, with its summer heat and round-the-clock air conditioning, is one big energy hog.
We only really have electricity we can use to cool the state. In fact, in the summer, almost 50% of our residential electricity usage goes straight to our air conditioning. I'm Dr. Rick Driscoll, Professor of Ocean Engineering, Florida Atlantic University. Florida's unique. We have over 80% of our electricity produced from hydrocarbons. None of those hydrocarbons are produced in Florida, and we have to import all of our hydrocarbons to produce the electricity. If that supply is cut off, Florida is shut down.
At the SeaTech Research Center in Dania Beach, Florida, Dr. Rick Driscoll is part of a team of scientists who are working on a rescue plan for the state and the rest of the country. They think they've found a way to power the entire state by putting a massive turbine farm on the ocean floor.
It's going to be about 10 to 15 miles offshore of South Florida, and it's going to be moored in about 1,000 feet of water.
As director of the SeaTech Research Center, Dr. Manhar Danik keeps his eye on the big picture.
Ocean energy is a really important source of power that can be harnessed.
Offshore South Florida is the best location on the planet to harness ocean current energy. We've got the largest flow of ocean water coming by our coastline, pumping over about 8 billion gallons per second.
That flow of ocean water is the Gulf Stream, the steadiest sea current in the world. But before they can harness that massive energy, they have some huge problems to solve.
It's not just taking that technology that exists in these wind turbines and sticking in the ocean.
Their turbines will have to weather the most challenging conditions.
You've got surface storms that you can encounter.
Storm waves can reach a height of 50 feet. There are destructive storms deep in the ocean, too.
If the current shifts and the turbine can't keep track, or if the turbine essentially becomes unstable, it could actually crash into the sea floor.
And connecting the turbines 1,000 feet below the surface will be a difficult engineering feat.
We obviously can put people in space, put people on the moon, but it's much more difficult to put them even down a few hundred feet in the ocean, sustain them there. Pressure is probably your biggest enemy.
At sea level, pressure is about 15 pounds per square inch. At 1,000 feet below the surface, it is more than 450 pounds per square inch, enough to crush equipment like a styrofoam cup.
You're fighting marine life that may be trying to eat your material, such as barnacles that may be attaching to your control surfaces.
Corrosive seawater and barnacles can roughen the surface of the turbines, creating drag and loss of efficiency.
If we're not careful in the selection of the materials that we use to construct it, then the turbine could essentially corrode, or parts of the turbine could corrode to the point that they break or they seize up the motion of the propeller.
Second is the sealing issues. You don't want to have fluids leaking out or the salt water leaking into your underwater turbines.
Despite the obstacles, the payoff can be huge, catching the power of the Gulf Stream. For those who have known its secrets, it's been paying off for centuries.
It started off as a trade secret where companies would be leaving the Americas and having to get back to Europe. The ship that could get back there the fastest would obviously have an advantage. So the company that knew about the Gulf Stream would hop in the Gulf Stream, arrive there 2 or more weeks earlier. I think Benjamin Franklin was, the first person to actually look at the potential for harnessing the Gulf Stream.
But Ben Franklin didn't have a laser tank.
Hi, my name is Carl von Ellenreeder, and I'm a hydrodynamicist working on the ocean energy current turbine here at Florida Atlantic University.
Carl von Ellenreeder is testing the performance of different turbines in various sea conditions. Finding just the right design is tricky. He needs to find one with maximum efficiency and minimum turbulence. It's a vital step before SeaTech actually commits to mooring a turbine on the ocean floor.
The blades could actually have a lot of vibration on them and perhaps break because of fatigue.
To help photograph the flow of water across the turbine, 2 laser beams are turned into a wide plane using optic lenses.
This water is seeded with small glass beads, and by taking the 2 pictures of the particles in the flow and comparing how far the particles have moved from one image to the other, we can calculate what the velocity is in the flow around the moving object.
The experiment shows Carl that there's a problem in the water flow between the turbine and the housing, known as the nacelle.
So what we noticed was that there's a region of slower moving flow right behind the nacelle.
To adjust the aerodynamics, he's recommending a longer shaft between the propeller and the nacelle. But there are more serious problems. The crisscrossing arrows show turbulent water.
Just sort of like when you're flying in an airplane and you encounter turbulence, the airplane will jump by several feet. The same thing will happen to the turbine blades.
Equally important are tests on the environment where the turbines will live.
I can grab it off of there. I gotta hook that bottom piece on.
The SeaTech team is headed to the Gulf Stream today on a fact-finding mission.
Okay. Gonna throw a couple on there. We're just gonna let it down to near the bottom at 600, so we're gonna let out about 750 feet of line. And then we're going to just pull it up slowly, and it'll give us a temperature and a whole bunch of anything you could think of just about. Yeah, hang on. Okay, now it's on.
As it travels to the bottom of the sea, the sensor will gather data on pH, dissolved oxygen, salinity, current speed, and direction.
That shows you the current. See it?
What are we at?
A little over 350.
The results show that the Gulf Stream currents shift direction by as much as 20 to 30 degrees.
Currents have a natural meander. They're like rivers in the ocean.
Like kites in a shifting wind, the turbines will have to fly into the current, and their moorings will have to be flexible enough to allow that.
You can perhaps fly your system, change depth, go up and down, to hit the optimal velocity, so you're producing power at your highest efficiency.
The data also shows that the Gulf Stream is strongest 150 feet below the surface. That means the Kevlar and steel cables with electric lines inside will have to stretch diagonally to the ocean floor, some 3,000 feet. They'll be shielded so that no electromagnetic radiation leaks out. That attracts sharks and other fish, and they would chew the cable to pieces. Also, the turbines must be designed in a way that they don't hurt marine life. Very soon, this testing phase will end, and the SeaTech team will begin to put the ocean turbines in place.
we could see thousands of turbines out there producing up to, say, 6 to 7 gigawatts of total power.
That's 1/3 of Florida's total electric consumption, and they have other big dreams for the future.
On the ocean floor, you might see something that would look like, say, a small water plant or perhaps a clean refinery.
The scientists are now designing a system that will use the cold, 40-degree water from the ocean floor to air-condition beachfront condos. They're also exploring yet another form of energy production.
We have the opportunity down there to generate hydrogen.
To make hydrogen, you need water and electricity. And once the turbines are in place, both of these will be available.
It will spawn up a huge new industry for Florida. This can have a huge impact, a global impact.
The ocean is an absolute incredible source of energy. It truly has the potential to change the planet, to power the entire Earth. And we are at the perfect spot here in the United States, in fact in South Florida, to harness that energy.
One of the most dependable and renewable energy sources on Earth could be the Earth itself.
The core of the Earth is very warm, so there's a big temperature gradient between it and the surface. So there's a natural flow of heat by conduction to the surface.
Tapping into the planet's heat to create electricity is called geothermal energy. It's a virtually unlimited source of power. But first, we need to go underground and harness that heat in the form of steam.
What's good about geothermal is all the power plants in the world run on steam. We have naturally occurring steam. Therefore, we don't need to burn any fuel.
Geothermal energy is available 24 hours a day, 7 days a week. And because of that, it has significant advantages over wind, solar, and other forms of renewable energy.
Only a small fraction of households use geothermal in the U.S. today. Why aren't we using more? This is Northern California's Bottle Rock geothermal plant. It sits on the largest steam field in the U.S. 15 years ago, it went bust. It had a hard time competing with cheap oil. And then the easy-to-reach steam began to fizzle out.
The facility had been abandoned. Areas of the facility were flooded with water. There were no phones, no working computers, no communication systems.
But the geothermal picture looks very different today. The price of oil has shot through the roof. Global warming is no longer a geeky scientific theory.
We have to do something in this nation with our renewable energy infrastructure. And geothermal energy is probably the best prospect we have. The plants have significantly less impact on the environment. We have almost no pollutants that come out of the facility.
And now, using enhanced geothermal technology, Bottle Rock is humming along once again.
This hiss is music to my ears. What you hear is steam passing through the pipe.
They got the steam hissing again by injecting water into the steam field.
The way that happens here is by using recharged water. That is water from local cities that is treated and then pumped to the geysers and put back into the steam producing area. And we bring that steam back to the surface and run them through the power plants and make electricity. At the present time, we bring in from 2 different sources about 20 million gallons per day.
The water is heated by the volcanic rock some 9,000 feet deep, shoots up a series of wells, flows through these pipes before pouring into the turbine at 325 degrees.
That steam goes through a turbine that spins a generator and makes electricity.
They're also using new drilling techniques gleaned from the oil industry.
One of the main differences is the elevation of the drilling platform itself. At the present time, we're sitting about 30 feet above the ground.
This allows us to drill at a very sharp angle to follow where the steam is and get more productivity out of it.
So what we try to do is we drill down for a ways vertical, say for instance to 5,000 feet.
Then they drill horizontally, trying to intersect deep fractures full of steam.
This steam flows directly to the power plant, and it will spin the machinery that makes electricity that goes out to the grid so we can turn on our lights, air conditioner, and watch movies.
Bottle Rock is now considered a green, state-of-the-art geothermal plant.
We're very excited about this project. This project is going to supply more than 30,000 homes with electricity, all renewable energy.
But wait a second. The heated Bottle Rock is found at a depth of only 9,000 feet. Does this mean you can only get geothermal energy when the heat is close to the surface? Dr. Jeffrey Tester of MIT believes that it's possible to extract geothermal energy anywhere on Earth, if you go deep enough.
We would like to go very deep into the Earth ultimately. It's an enormous warehouse of energy that we could utilize. Many, many thousands of times the primary energy that we consume annually right now in the United States is literally under our feet.
If you go down far enough anywhere in the world, there is hot rock down there, and you can extract the heat from it.
Just how much energy is down there? The west coast of the U.S. is seismically active and very hot. If we go down 6 miles below St. Helena, California, the temperature is nearly 600 degrees Fahrenheit. But what about the East Coast? Let's take a dive into the Earth's crust below Raleigh, North Carolina. 2 miles below the surface, temperatures will hit 120 degrees Fahrenheit. Descending further into the Earth, at 6 miles, the temperature is approaching 400 degrees. The greatest challenge to extracting that energy has been drilling precisely several miles into the Earth and keeping the cost down. In conventional drilling, each time a bit breaks, you have to pull out miles of tubing and start all over again. Jeffrey Tester and his PhD student, Chad Augustine, believe they have the solution.
We're going to do methanol from now on instead of hydrogen, because it's easier to start with, it's easier to control the flame.
They're designing a completely new drill, which will burn its way through rocks deep into the Earth.
It's really essentially like a rocket engine that produces this flame that had a diameter of about 5 to 6 inches. And what we're trying to do is to use a thermal source, a flame of sorts, to thermally cause the rock to fracture and melt.
In his lab, he is simulating the high-pressure conditions deep inside the Earth.
We have to go deep into the Earth where we would have water-filled holes and have to produce these flames in a high-pressure water environment. So that's what's different about it, and we're hoping that these experiments we're conducting here will be able to demonstrate the feasibility of that technology.
Hot, dry rock would work like this. Engineers drill as much as 6 miles into the Earth. They fracture rocks which are heated up to 600 degrees Fahrenheit. They then inject water into the system through one borehole and pump the water out through a second hole. As it returns, the superheated water can run a turbine to produce electricity. Hot, dry rock could meet all of the Earth's energy needs for thousands of years. But all geothermal energy comes with one small hitch: earthquakes.
The black line here that I'm drawing is the magnitude 3s and above. Still very small. You can feel them. They're felt in the geysers.
Seismologist Ernie Major sees a relationship between small earthquakes around the Bottle Rock plant and its new water injection techniques.
Started injecting water, and they have several peaks here in water injection. So yes, the seismicity has risen over the years, but the hazardous seismicity has not.
We do have some more earthquakes. There is a cause and effect, but it is a fact of life and we all live with it.
People in other parts of the world are not so blasé about quakes. Some very deep drilling was recently halted in France.
This is a map of Europe. It shows you right here, this is Soultz, the French geothermal area that people have been talking about in which seismicity has caused a problem.
Another recent earthquake took citizens of Basel, Switzerland by surprise.
It basically caused a magnitude 3.5.
Ernie Major insists that the quakes aren't strong enough to be dangerous.
It's just a matter of doing the proper research to understand what's causing these earthquakes and how to control these earthquakes, because they can be controlled. We made them, we can stop them.
With public support and hot, dry rock technology, geothermal may be ready for its great leap downward.
There's an awful lot we can do right now to make this a much larger, usable resource for our country and for other countries.
Dr. Alan Heeger of the University of California, Santa Barbara dreams of bringing solar power to everyone.
The sun is shining. The energy that we receive from the sun in 1 hour here on the Earth is sufficient to handle the energy needs of the entire planet for a year.
Naturally, he enjoys the conventional photovoltaic solar panels on his house.
The power from the solar cells is coming down through this cable into the house. This is our electric meter. When the sun came up this morning, the meter started running backwards. We're selling electricity into the grid.
But as a scientist, he was frustrated. A half-century after their introduction, silicon-based solar panels remain bulky, rigid, and most of all, they cost too much.
The main problem with the current technology is the expense. The time to recover the investment is something like 8 to 10 years.
Alan Heeger set about making the sun's energy more affordable for everyone.
So the goal that we have, the dream I should say, is to create a technology for low-cost solar cells.
First, he needed a cheaper material, plastic.
And there was a moment of discovery which really enables this whole enterprise toward plastic solar cells.
That was the day he mixed plastic with a fullerene, a carbon molecule, and forever changed the world of solar cells. To his surprise, the electrons in the plastic started moving. Today, Alan and his team are testing the speed at which their latest solar cell conducts electricity. It's even more efficient than they expected.
This is really exciting because it happens in a time scale even faster than the first steps of photosynthesis, 1,000th of a billionth of a second. That means it's very efficient.
Using different plastic and fullerene combinations, Alan has made several kinds of solar ink. Each one absorbs a different wavelength of the sun's energy.
They can be viewed as inks. They can be formulated as inks. They can be printed as inks.
Now, solar ink can be sprayed on any surface in layers. Each layer responds to a different wavelength of light.
It already has the titanium oxide on.
With this solution, solar cells can be rolled out like newspapers on a printing press.
These kinds of unexpected discoveries are part of what makes science so exciting. You cannot plan on them, but you're really happy when they happen.
Alan Heeger's putting his theory into practice at a Massachusetts-based company called Kanarka.
The most revolutionary thing out of this technology is that it can be mass-produced at very high speeds and very high volumes.
Alan Heeger and Kanarka are on their way to making solar energy in the form of power plastic mainstream.
All the magic happens here. This is our unique coating technology. These coatings are very thin. They are 1/10 of the human hair in thickness.
Power plastic is a whole new breed of solar.
They can pick up very low light, like cloudy days. And even right now with these lights, these tiny cells are producing electricity. They can also gather light at off angle. Most solar cells have to be pointed directly at the sun.
Portable electronics, the cell phones we carry, all of the many different electronic devices that are so dependent upon being plugged in for recharging. These devices now would have the ability to self-charge themselves. You set it on the table and the light above the table would be recharging the battery inside the device.
Power plastic should be available very soon, and by 2010, you may be able to power up your house this way.
The solar cells can conform to the contours of the roof, where even one day the solar cells can be built into the roofing tile.
While conventional solar panels cost $2.40 per watt of electricity, these are currently below $1 per watt. Once it gets out of the experimental stage and into large-scale manufacturing, they believe they can get it down to 10 cents per watt. Alan Heeger's dream of a world without wires may be right around the corner.
The implementation of solar cells on a large scale is such an opportunity. We have to take advantage of it.
Work harder, work harder. Okay.
Now, What if you could harness the sun's energy without having to make any special photovoltaic cells at all? That's what Antonio Esteban is doing in Seville, Spain. Like a lot of kids, he learned in school that you can concentrate the sun's energy with a magnifying glass. Today, he's using that same concept to try to power the entire city of Seville.
We are now in the PS10 plant.
Instead of a piece of paper, Antonio now has a tower that stands 40 stories tall.
This is a central receiver solar power plant.
It's the only commercial solar tower in the world.
We have here the field of heliostats.
Those are high-quality mirrors mounted on remote-controlled motors to track the path of the sun all day long. Those heliostats can fail. They've done it before at a different tower, Solar One, in Barstow, California. Behind the mirrors in the California plant, engineers had used concave foam pads to help focus the sunlight and to absorb shocks from storms. But moisture collected between the foam and the metal casing and back. The mirrors corroded and lost their efficiency. In the end, the plant's energy was considered too expensive. That lesson wasn't lost on Antonio Esteban, who was beginning his career in solar energy. His heliostats have no foam and no moisture.
They are tracking the sun every moment to focus the solar radiation onto the receiver, which is at the top of this tower.
The mirrors reflect the light of 624 suns on a receiver at the top of the tower, raising the temperature up there to 500 degrees Fahrenheit.
In the top of the tower, we have a receiver, and in this receiver, we produce saturated steam.
That saturated steam, produced inside a network of stainless steel tubes, is piped down the legs of the tower to the heart of the system.
This is the turbine. It's 11 megawatt power, nominal power, and in this turbine, with the steam from the receiver, we produce electricity, and we send electricity to the grid.
This region of southern Spain is blessed by sunlight, some 3,000 hours per year. But even here, the enemy of solar power can appear at any moment: rain clouds. Antonio springs into action. He has a backup plan, a storage system.
We can store energy here to operate the plant in the case we have a cloud.
The trick is to design the solar tower so that it makes more heat than the turbine can use. That extra energy gets stored for a rainy day. But Antonio is just getting warmed up. He's got bigger plans.
In 7 years, we will have the construction of all this solar platform, and the nominal power of the solar platform with the 9 plants will be 300 megawatts.
That's enough to power the entire city of Seville, Spain, and its 600,000 residents. And it's all done with mirrors. A second plant will go online soon.
Now we have under construction the PS20 plant.
This one will have, instead of steam, a molten salt inside the tower, which can retain heat much longer and continue delivering solar power even at night. By 2014, the entire city will be powered with clean, renewable energy.
This plant also avoids the emission of CO2 to the atmosphere of about 18,000 tons per year.
Consider this: a similar plant, built on about 1% of Africa's Sahara Desert, could provide enough electricity to power the entire world. One day, the subways all stopped, the air conditioners shut down, and the lights went out for 50 million people. August 14th, 2003. It was the biggest blackout the U.S. had ever experienced.
The entire grid came down, just like a house of cards.
and we can expect more of these massive power failures.
The grid as it exists right now is very much like a very, very, very feeble old person.
The electricity flows typically for hundreds, sometimes or for thousands of miles through these frail aerial arteries. It's kind of miraculous it works at all.
But Bill Becker is hopeful and gets inspiration from his hero, Buckminster Fuller, a scientist and a visionary, best known for one of his creations, the geodesic dome.
Like Bucky Fuller used to say, there really is an energy crisis. There's a crisis in imagination.
He imagines a future with a much more efficient and reliable energy grid, one based on distributed power.
Distributed power is power that's generated locally, so it's power that's generated where it's being used.
Lots of little units are more reliable than a few big ones because they're unlikely all to fail at the same time.
Bill wants to see his city of Chicago with a distributed energy system of wind power.
Wind power is the cleanest of the energy sources, and it's the most readily available for us to take advantage of to move away from global warming gases.
He pictures a wind turbine on every building in the city.
A building can be a producing entity in terms of the common power grid.
There's a lot of wind energy out there.
Engineers and others will ask us, is there really enough wind in Chicago and cities? And there's a tremendous amount. There are 72 terawatts of usable wind energy in the world. The world only uses about 8 to 9 terawatts of energy.
But urban wind energy, capturing that is a whole different ballgame. Wind turbines are based on conventional windmills, invented many thousands of years ago. They work well out in the open, where wind flows steadily, turning a generator inside to make electricity. But in the concrete caverns of Chicago, the wind flows erratically around and over buildings. The whipping action of winds coming from different angles causes the long blades of a conventional wind turbine to flex and twist. It's dangerous and unstable in a city. At first, Bill tried a conventional turbine on his building.
It proved to be very difficult and actually scary at times, with ice throws, near runaways, and a lot of vibration and noise. So it taught me that the propeller was going to have a hard time functioning in Chicago.
So Bill looked for a safer way to tame the urban wind. His imagination took off one spring day while he was watching the movement of sailboats. He'd read about an inventor who'd made a spinning sail which ran a propeller. Bill's gears started turning.
I began building different kinds of machines.
We got to get rid of one of these batteries because the torque transducer. This has to go, and we got to use the universal joint.
After years of experimenting, he has a design that is his own creation.
They have a helical DNA-shaped center. We call it the helix.
He has combined the DNA shape in the center with a pair of airfoils on the outside. The result is a turbine that spins in the slightest breeze.
The S-rotor is an extremely good form for starting up the spinning of the turbine. The airfoils will give us a higher end speed to get the kind of power at the high-end winds that we also need.
It's not completely understood why, but while regular wind turbines can spin off their shafts at very high speeds, Bill's DNA turbines do not.
They never spin faster than 380 RPM. They never make a lot of noise because of that lack of overspin. They don't throw ice. They don't cause other kinds of concerns like centrifugal force spinning and throwing things away, like blades.
The slower speeds are safer for birds too. And while traditional wind turbines don't do well with turbulence, Bill's designs, with their large surface area, seem to thrive in it.
This machine, we found through testing, seems to enjoy or even like turbulent winds. When it's vertical, it can take winds from all directions at once. It spins in the axis of its support, so it's more like a gyro spinning. The faster it spins, the more stable it is, and it takes winds from all directions. Very important in the city because the winds will whip around and be multi-directional.
13 of Becker's turbines are currently generating power in Chicago. One building is specially designed to capture urban wind.
Here we are at the Helmut Jahn designed building for Mercy Lakefront Housing in Chicago. We have 8 of our wind turbines on the roof of the building. The architect had a concept that the curved roof on the building could operate and help power the wind machines. So the building shape and the wind machine placement is reciprocal. It's not random.
The wind is converted into utility-grade electricity by a computer system.
This is a battery-free system. It's very high in efficiency, no noise, no vibration, and very, very safe.
When people call his urban wind turbines beautiful, Bill proudly recalls his idol, Buckminster Fuller.
Bucky said, if what you're designing doesn't turn out to be elegant or beautiful in some way, you're probably going down the wrong track.
Are they going to be hybrids?
You could add solar in at the end and it would be hybrid. Yeah.
Okay.
Growing demand for his urban wind turbines is affirming too.
We have an evolving agreement in India to produce our machines there for 120,000 villages without really sustained power. We're developing a program in New York State and one in Italy. We're going to start one building at a time. We hope to see a revolution here really take off in the next 10 years.
As scientists and engineers seek to power the world without fossil fuels, one thing is clear: no single technology will do the job.
So the next efficiency revolution is in integrative design. Of course, the technologies keep getting better, but the way we put them together is the real secret sauce.
It's a feat that one town is trying to master. This is Malmö, Sweden. This used to be a contaminated shipyard. Now, it's the gold standard of energy efficiency.
My name is Per Rosén, and here we try to produce as much energy as we consume.
Per Rosén is the technical brain behind its conversion.
You really believe in it yourself when you're starting building it, and everyone has to work to reach this goal.
If you have trouble believing in it, the Turning Torso building will twist your mind around the idea. 54 stories of offices and apartments. It uses 100% renewable energy. Interior lights are all highly efficient LEDs. Waste not, want not.
The organic waste, food and flowers that we don't use anymore, we take them and put them in a basket and throw them into the system that goes away and produces biofuel that we can use in the energy system.
One of the lessons of Malmö is that if you're going to succeed in the energy game, you've got to be a show-off. While most cities hide their power stations, Malmö flaunts them.
There is always a point on showing what you have done.
Case in point, this building sports a 154-ton solar hat. It started as a small-scale model, but now it's real. Almost 1,500 square yards of photovoltaics. They shade the building from summer heat and deliver more than 10 kilowatts of renewable energy, enough to power the whole building.
We try to visualize the energy system, and here you have an example on the wall of this building. We have put up solar collectors to produce heat, and we think it's very important to have visualized the energy system, because the people living here, they start to think when they go past this building, and that means the consumption goes down.
Pedestrians rule the streets of Malmö's Western Harbor District. Parking is limited to 0.7 cars per apartment. Driving 7/10 of a car is difficult, so most people walk or cycle. Water is everywhere in the city. It's all recycled rain, trapped on the roofs and cleaned naturally before it goes out to sea. Many of the streets are modeled after the medieval towns of Sweden. This is eco-living in style.
You could say that the area, eco-luxury area, where you have even higher comfort than you have in other living areas here in Sweden.
But you don't have to be rich to be green here. More than a third of the apartments in the Western Harbor area are designed for students.
It's cheaper to live when it's renewable.
The secret to keeping costs down is an ingenious juggling of the forces of nature.
This heat pump is the heart of the energy system in the Western Harbor.
300 feet below the city, there is an aquifer, which becomes a kind of holding chamber for either cold or hot water, depending on the season.
During the winter time, the sea is icy cold and with storage below the city. And during the summer, we take it up again and use it as air cooling. So it's a balance. You take out heat in the winter and coolness in the summer, and you fill up and go down in energy levels below the city.
So why isn't every city in the world doing this? The magic of Malmö is based on an emerging field of green science.
I think the most exciting thing is not particular technologies, but smarter ways to combine them into whole systems.
In Malmö, everything and everyone is on a mission to make more energy and use less. It's important to note that this is an awful location for capturing solar energy.
This is not especially for a Swedish thing. It can be done anywhere. The thing is, Sweden is not the perfect place to do it, because it's in the north of Europe, and the solar times are really bad. Anywhere in the world could probably be better. But still, we're producing and it's working.
Living here is absolutely not more complicated than living in another area. I would say rather the opposite. It's easier to live here.
The success of Malmö has inspired other cities. Abu Dhabi in the United Arab Emirates, despite 120-degree summers, is about to break ground on a carbon-free city. Companies that contribute to the effort will receive carbon credits.
The thing most people don't understand about climate change is they assume that solving this problem is going to cost us extra. I got news for you. Climate protection is not costly, it's profitable, because it's cheaper to save fuel than to buy fuel.
Based on the lessons of Malmö, a new energy model is taking shape.
In the future, better solutions in how we design our communities, how we design our public transit, how we actually meet the needs that we have to, say, go shopping, and the way we can make more efficient our logistics and distribution system.
The science and technology that will make this possible are emerging quickly.
As we continue to do energy research, a lot of really nice surprises are turning up. Some things we thought would be really hard to do are turning out not to be quite so hard.
The game changer will be to snip this tie between energy use and supply and carbon. So what we need to do, any energy source that is carbon neutral, that's biomass, it's geothermal, it might be tides, it's wind, it's solar.
And that game changer is already on the horizon.
There is tremendous potential to use innovative thinking, to use engineering, to use designs, and use technologies to radically reduce the energy and electricity and resources we need to meet our fundamental needs.
The barriers to doing this are not technological and they're not economic, they're institutional. For example, in 48 of the United States, we reward utilities for selling you more electricity and penalize them for cutting your bill. So guess what they want to do? Well, this is just as dumb as a possum. We ought to stop doing it this way. We ought to reward what we want, not the opposite.
With market incentives, a stronger, renewable power grid can be built, which will rely on many different sources of energy.
To date, renewable energy has always been at a separate location on its own and a conventional power source at a separate location on its own. If we can take existing infrastructure and complement that with geothermal steam to produce more power or just replace a portion of the fuel source of a conventional power plant.
Integrating those energy sources will result in a balanced system. Across the world, scientific research and technology are creating a new energy model.
It's just such an incredible opportunity to be here and being on the forefront of this technology.
Time that's come. Wish I'd gotten a little bit ahead of the curve, but here we are, we're going to do our best.
I'm excited by the whole range of progress in energy efficiency. Efficiently used renewable energy can make all the electricity we need. I think as that good news spreads, the resistance is going to melt faster than any glacier.